Unit 2. When a ball falls down, potential energy changes to kinetic energy. When it rises up again, kinetic energy changes to potential energy. This keeps the mechanical energy value constant, which is known as conservation of mechanical energy. So when a ball falls down, potential changes into kinetic, and when it rises up, the vice versa occur. Kinetic energy changes to potential energy. So this keeps the mechanical energy constant, okay, which means that law of conservation of activity to prove the conservation law of mechanical energy. Step 1. Hang a ball with a thread as shown. Pull the ball to be in A, then release it. What we observe? The work is done to pull the ball. The ball gained this work in the form of potential energy in A. When the ball is left, potential energy changes gradually to kinetic energy. And when the ball passes its original B, it has maximum velocity, maximum kinetic energy, potential energy equal 0. And when the ball reaches its maximum height, do you remember? So potential energy will be maximum. Okay, when the ball reaches its maximum height, the velocity is 0, kinetic energy is 0, so potential energy is maximum. We conclude from this activity that the object saved its mechanical energy, which changes between potential energy and kinetic energy. Okay, again, when the ball passes its original position, يعني bypassing its original position, okay, اللي هو B, it will be maximum velocity, maximum kinetic energy, so potential energy is 0. And when the ball reaches its maximum height at A and C, the velocity will be 0, kinetic energy will be 0, and so potential energy is maximum because it is at maximum height. So what is the law of conservation of mechanical energy? The sum of potential and kinetic energies of an object under the effect of gravity is constant value. Again, sum of potential and kinetic energy of an object under the effect of gravity is constant value. Examples: the arrow of a bow, when it is stretched, work is done on it is stored as potential energy. Again, when it is stretched, work is done on it is stored as potential energy. When the arrow is thrown, potential energy changes to kinetic energy because any movement body, okay, has kinetic energy. Children swing like pendulum. The sum of potential and kinetic energy at any moment is constant. Law of conservation of energy. Energy can neither be created nor destroyed, but changes from one form to another. Okay, again, what's mean by law of conservation of matter? What's mean by law of conservation of matter or law of conservation of energy? Energy can neither be created nor destroyed, but changes from one form to another. Okay, let's make an activity, a model of the simple electric cell, changing chemical energy into electric energy. Step number 1, press a lemon to increase its juice. Dip a zinc rod and a wire into the lemon. Coil the wire around the compass and tie the other end around zinc piece. Okay, what we observe? The compass deflects, indicating that an electric current flows through the circuit. The compass deflects, indicating that an electric current flows through the circuit. Okay, what we conclude? In the simple cell, chemical energy changes into electric energy. Okay, let's talk about the idea of simple cell. Idea of operation: it converts chemical energy into electric energy. Its construction: it consists of a glass containing dilute sulfuric acid, H2SO4. Two metal plates are immersed in the diluted sulfuric acid, and one of these plates is copper, which act as a positive pole, and the other is zinc, which act as a negative pole. As we show in this figure, copper and zinc. Copper is positive and zinc is negative, and the two plates are immersed in a glass vessel containing dilute H2SO4, which is sulfuric acid. The direction of the passage of the electric current in the wire from positive copper plate to negative zinc plate. Transformation of energy in the electric lamp. The electric energy changes to light and heat energy. The electric current flows through the closed electric circuit. So what's mean by electric circuit? It's a closed path of electric current through conductors. It consists of what? Battery, connecting wires, lamp, and switch. This is the figure of simple circuit. As we see in this figure, we see the switch, battery, electric wire, and the light bulb. So it is a closed path. It is a closed path. Changes of energy inside the car. Okay, here are the car constituents, like car motor, change electric into kinetic energy. Car dynamo, kinetic energy changes into electric energy. In car lamps, like any lamp, change electric energy to light energy. Radio cassette, electric changes into sound energy. Electric heater or air conditioner, electric energy changes into heat energy. Okay, another application for changes of energy: sewing machine, electric changes into mechanical. Torch, electric changes into heat and light. Television, electric changes into sound and light. Alarm clock, electric changes into kinetic and sound. Washing machine, electric changes into kinetic energy. Dry cell, chemical changes into electric. Okay, inside the car, when the fuel is burned, chemical energy changes into heat energy, which changes into mechanical energy, and mechanical energy changes into electric energy in dynamo. So in dynamo, mechanical changes into electric. Electric changes in the car lamp into light, and it changes in radio cassette into sound, and it changes in electric heater into heat energy. So these are the changes inside the car. Okay, so simple cell change chemical energy to electric energy. Electric lamp from electric to light. Sewing machine from electric to kinetic. Solar cell from solar energy to electric energy. Okay, television from electric to sound and light. Alarm clock from chemical to kinetic energy. Cellular phone from radiant energy to sound energy. Okay, the last slide about the negative effects. Okay, environmental pollution, technological application, negative effects. Number one, car exhaust. It causes a chemical pollution for air which cause chest and eye diseases. Number two, military explosions. They have or they leave harmful effect and diseases and cause death. Chemical pesticide, they cause chemical pollution for soil, water and air and hence cause cancer. Nuclear weapons, they cause the massive destruction. The webs of wireless transmitters of cellular phones, they cause electromagnetic pollution. Loudspeakers and drilling machines, they cause noise pollution. Thank you.